here we go. So we looked at this parabola. We selected a point. Okay, we said that this point was a distance of, again, y plus 1 from the line, the directrix, right? Okay, and we said that with a focus point here, a fixed point here, we saw that this length in black right here had to be equal to the length in green, because that's the definition, right, of a parabola. Okay? Does anybody have any tips for how to evaluate if the vertical length here is y plus 1? It would be interesting to investigate what that is equal to in terms of this line here in black. So was anybody able to evaluate or find a way of coming up with an expression in terms of x and y for this length right here? That's what we want to figure out. What do we think? Kira, yeah, how did you approach it?
Well, Megan explained this to me.
Great, well, let's see how you're explaining. Megan, props to Megan, but yeah, Kira, explain it now to us.
So we know that the geometric definition of a parabola is, or no, that's the wrong way to start this. But okay, we know that every point on the parabola is equidistant from the focus and the directrix.
Right.
So if we know that from point P to the directrix is y plus 1, right? We figured that out in number 2.
Got it. Yep.
And we know that that line is equal to the hypotenuse, or to from the focus to point P.
Right. It's equal to this. Right. These two lengths are equal. Keep going.
Then we know that that line is also equal to y plus 1.
It is. Good. Right, so we know that this line does have to equal y plus 1. Sorry, that equals y plus 1. But does it need to equal anything else? Is there another way of expressing that length? I agree, these two lengths have to be equal. But is there another way of Diana expressing this length? Yeah, in black.
We looked at it more like the Pythagorean theorem, that if we were to draw a line from the focus to where it meets the y plus 1 line.
Sure, so we draw a little horizontal line here, and then we've got this vertical piece right there.
And then if we were to take that out of the graph, it would be one side would be y minus 1, and then it'd be x there, and then the hypotenuse would be, if you were to write y minus 1 squared plus x squared equals c or d squared. That's the Pythagorean theorem.
So we use the Pythagorean theorem on this triangle right here. Love it. Okay. And it's interesting, and I like, again, the evaluation here in finding this height right here as y minus 1. I agree. That is correct. All right. So now we're able to solve for the distance squared, and we see that it is x squared plus y minus 1 squared equals d squared. It is time to go to break. When we return, the gripping conclusion, and we'll ask our question, if given a parabola, it is possible to find the focus and directrix. See everybody in 15. You ever heard that when we last left our heroes? It's like how you get back. So where we last left our progress here, okay, we were talking about the fact that these two segments are equal, and we found two different equations for those segments. All right, one saying that the segment squared was equal to, you know, the two, right, the Pythagorean theorem, right, the sum of the squares of the legs of that triangle. And then we said that the distance itself was also equal to y plus 1 by the definition of the parabola. Okay? And the goal is now to find some equation, some function of the form y equals something. Okay? So how might we do that? Now that we've got these two different equations, they share something in common. I'm wondering how we can use that. Yeah, Megan, there you go.
We can rewrite x squared plus y minus 1 squared equals distance squared with like the y plus 1 squared substituted.
Right, so Megan suggests substituting in the distance from one into the next. So we could have, yeah, y plus 1 squared equals x squared plus quantity y minus 1 squared. Whoa! Gosh, now we have to do what? What are you trying to do? Just,
Then you just simplify it by using the formula.
right, just distribute, simplify. So I'm going to do this kind of quickly here. Y squared plus 2x plus 1 equals x squared plus y squared minus 2x
Y.
Minus 2.
plus 1. Oh, yeah, y. Jeez. Yeah, how'd that get in there? Y plus 1 and then y. Okay, great. So then we can combine like terms, simplify, right? So y squared. So I've got 2y plus 1 equals x squared plus 1. So, oh, plus,
2y.
gosh, thank you. I'm going too quickly here. Minus 2y, thanks. Minus 2y plus 1. Subtract 1 from both sides, so 2y equals x squared minus 2y. So, trying to get y alone, so we've got 4y equals x squared. It's the last step we need here to solve for y.
Divide 4.
Divided by 4. Y equals x squared over 4. Which is the equation of what? Right, the original parabola here in blue, right? Cool, so that's y equals x squared over 4, okay? Important method there, using the geometric definition of a parabola, which gives us that these two segments are equal. We find two different equations for each of them, set them equal, do a little bit of algebra, and find an equation for the line. Cool. Here we go.